An upgrade video? What am I looking at here? You're looking at my original plasma table. A basic machine with a water pan, built to get the job done. Yeah, sure, it worked, but it was far from proficient. Over time I realized I needed more than just functionality. It needed upgrades. This is the machine running with the upgraded torch. I recorded this footage about a year ago, so I don't have specific details of the cutting speeds or air pressure. But the nozzle on the CNC torch is 1.1 millimeter, whereas the nozzle on the hand torch was 0.8 millimeters. Alright, now the main goal here is to show you the cutter in action. You'll notice that the probing speed is incredibly slow. I found that when I try to speed it up, the cutter sometimes attempts to pierce in midair. I have a feeling it might have something to do with the probe trigger switch not being shielded. Now, if anybody has a solution to this issue, please let me know. And here's the part fresh off the table. I'll clean up the dross here in a moment. And here is the overall view of the machine. Takes up a lot of headroom. Now the issue I was talking about before with the probing touchdown and it sometimes starting an arc in midair, I'm wanting to say that's due to the switch, if I can get around here, not being shielded. I mean, this is just speaker wire, and it runs the entire length unshielded. So I may have to pull that out, shield it, and then see what happens. Alright, now the original handheld torch that came with the cutter had issues right from the start. No matter what I tried, I could not get it to cut consistently. My solution was to upgrade to a CNC torch. After doing a lot of research, I found out that the Tecmo torch was the torch to get. I didn't go for a warranty claim on the Lathes because the plasma cutter came with a power cable that I wasn't comfortable using. According to the manual, since I'm powering it with 220 volts, the maximum inrush amps would be 46.7 amps. Too much for the supplied cable. So I upgraded to a 6-gauge cable. Of course, by making their product safer, I ended up voiding my warranty. I feel like that should make it very clear that I did not attempt to dial in any sort of settings for these test coupons. But I do know that the settings are the same between the two. So here's the original cantilever arm. I printed these out. I didn't really know my print settings. It worked. The issue I ran into was the bearings. For some reason I could not get them to line up right. So when I would roll this thing down the square tube, it would just sound like cracking, because it was just destroying these crappy bearings, and it just started to irritate me. So jump over to linear rails. I've got the rails installed. I'm working on these brackets here. I don't have the other one installed right now. And that's going to sit in there. And then under that, I'm going to put a plate. So that plate will bolt right there. And then I'll have some screws coming up where these are. Okay, making pretty good progress here. Got that plate bolted up. Got this extension arm. I'm going to have to figure out how to transfer those holes from here to here. Okay, it is mounted up. I got the drill hooked up to it. The lead screw kind of wobbles. I don't know if I like that or not, but is what it is. As I was making this video, I realized I totally forgot to include this portion of it. How am I going to drive this ball screw? I initially wanted to do just a direct drive, just have the motor hanging off the side, but ran out of real estate. Luckily, I could repurpose this bracket from the original design and just do a 1-to-1 gear ratio using this belt drive. So far, it's worked out really well. I've also got this protective plate up here. Kind of just, protects the ball screw and the computer that sits underneath. You may have noticed the cuts on the last piece were a little serrated. I attributed this to a shaky table. To fix this, I decided to add some wood bracing. Wood being a little more rigid than steel. Cheaper too. It worked great, actually. After upgrading the bracing on the table, the cut quality improved, like, dramatically. So I cut these rectangles out maybe a few weeks ago, a month ago. This is 1/4-inch material. Yeah, it's got a little surface rust on there, but it looks pretty good. These were used to build my gantry crane, which I will be using to make a flatbed for my pickup truck. I'll also get a lot of use out of the plasma cutter for that project, so stay tuned. Alright, that about wraps it up for the plasma cutter video. I only need to make one more change to it, and I will be 100% satisfied. I just need to add this cross member going this direction, and I'll show you why. Push it this way, we're good. It's not bolted to the floor. Push it this way, no good. So that'll be the last change, and I will be done. If anybody's out there building one of these machines, I highly suggest making your frame as rigid as possible. Thanks for watching.